Let's go ahead for Cloud Maths. Today we're going to do through the Higher Maths 2024 last minute calculator paper, courtesy of Chris Smith. Make sure you check out his videos and sign up to his newsletter, link in the description. Let's get started straight away. Okay, number one, express root 3 sin x plus cos x in the form k sin x minus a. So, and then we have to find the maximum value of it. So it is a wave function question to start us off with. So we write root 3 sin x plus cos x. Let me do that underneath. Root 3 sin x plus cos x equals, and it's k sin x minus a. So k sin x cos a minus k cos x sin a. That's just straight from the start of the exam paper for k sin a minus b. Yep. So now we compare the coefficients. So some people write it underneath. I use a different coloured pen. I've got sin x here and sin x here. So that means that root 3, the thing in front of sin x, equals k cos a, or k cos a equals root 3. And then using another colour, I've got cos x here, and I've got cos x here. So minus k sin a equals 1. Because the number in front of cos x is 1. Now, if they were both minus, I would just drop the minus, but since one's minus and one's plus, I'll need to keep it in. Hopefully we're doing well so far. And now we can work out our k. So let's just rearrange these two equations. I'll just use a pen. We've got k sin a from the bottom one equals minus 1, just dividing through by minus. And you've got k cos a equals root 3. So k, remember, by Pythagoras is the square root of minus 1 squared plus root 3 squared. That's the square root of 1 plus 3 root 4. So k equals 2. And now we can work out our angle. So tan a, sine divided by cos. So we're looking at here, minus 1 over root 3. So we'll do the inverse tan, not of the negative, of the positive, 1 over root 3. And I don't really care if it's the exact value or not, because I'm going to use a calculator anyway. I'm in degrees, make sure I'm in degrees. Shift tan, 1 over root 3, close the bracket, 30 degrees. Now, I didn't know that was an exact value, but we're on a calculator paper, so why give ourselves a headache? And then it's a cast diagram. We need to verify which angle it is. Well, how do we do that? Well, we don't use the fact that tan's negative, because that would give us S and C, which is 2, and I only want one of them, so I'll go back to the original equation. Sine is negative, so when sine is negative, it's T and C, but we've also got cos is positive. Well, cos is positive at A and C, so I'm picking the one which has got 2 ticks, so that means that A equals 360 minus 30, which is 330 degrees. And now we can write our answer with root 3 sin x plus cos x. So root 3 sin x plus cos x equals k, which is 2. And then it was sin x minus a. Sin bracket x minus 330 degrees. And we're done there. Part B says, hence let's find the maximum value of root 3 sin x plus cos x. So just compare that is exactly the same as that and not a multiple. Sometimes it is, but it's exactly the same in this case. So for part B, the max value is y equals 2. Because if you were to draw a graph of this is the whole power of the wave function. The max value would be 2 because it goes up to 2 and down to minus 2. And we have Maths 2024. Paper 2, question 2 for the last minute. Calculate is set to 3 significant figures, the size of the angle in between these two vectors. So from the start of the exam paper, you've got A dot B, and you've got 2 versions of it. So I'll do the first version first. You times the numbers together, so 3 times minus 1, plus minus 1 times minus 5, plus 4 times 9. So you can work all that out, use a calculator anytime you want. You get minus 3 plus 5 plus 36. That's 36, 41, 40, 39, 38. So A dot B is 38. But also at the start of the exam paper, it tells you that A dot B equals the size of A times the size of B times the cos of the angle in between. So that means that rearranging that formula, cos theta must equal A dot B, which we already know, over the size of A and the size of B. So we need to work out the size of A and the size of B. So let's do the size of A first. The numbers are 3, minus 1 and 4, so it's just the square root of 3 squared plus minus 1 squared plus 4 squared. I'll leave it as a third and not even simplify it because I'm going to do a calculator to get the angle. So that is 9 plus 1 is 10, 10 plus 16 is 26. So there we are. And the size of B is the square root of minus 1 minus 5 and 9. So minus 1 squared plus minus 5 squared plus 9 squared. That's the square root of 25 plus, well, I can't be bothered to see if that's the whole point of a calculator. 1 squared plus 5 squared plus 9 squared. Not so much we want to use the minus because a minus is a minus is a plus. That's 107. So now cos theta equals 38, that's A dot B, over root 26 times root 107. So I can now do the inverse cos in my calculator to get theta. Shift cos 38 divided by, open a bracket, root 26 times root 107 is 43.9 degrees to 1 decimal place. And we're done there. The points of intersection of the line y equals x plus 4 and this circle. So if it's a point of intersection of anything, whether it's a circle, whether it's a curve, you're doing simultaneous equations. Now, if with this type, you've got y equals and then you've got a funky equation. So you just sub in that y into the funky equation. So we've got x squared plus y is x plus 4, so x plus 4 squared, plus 8x plus 2, y is x plus 4 again. And I can't even read those numbers, so let me just see my notes. I think that's a 96 it's meant to be, so minus 96. And that equals 0. Expanding the brackets, x squared plus x squared. And then it's going to be 4 times 2 is 8x. Then 4 squared is 16. Plus the extra 8x. 2 times x is 2x. 2 4s is 8. Minus 96 equals 0. So how many x squares have I got? 2x squared. I mean, I've got 8 and 8 is 16, 17, 18x. And then the number parts, this is where I'm getting lazy. 16 plus 8 minus 96 is minus 72. Now that's handy because 2 is a common factor of all of that, so I'll take 2 out. X squared plus 9x plus minus 36. And then I'll factorise. Hopefully, anyway. So I went for 2 numbers at times to make 36, but add to make 9. So you've got 6 and 6. You've got 12 and 3. 12 and 3 is going to work. So I would say you've got plus 12 minus 3 is 9. So that means that x equals minus 12 is the first root and x equals 3. We want the points of intersection, so we use y equals x plus 4. So when x is minus 12, y is minus 12 plus 4, which is minus 8. So the first point is minus 12 minus 8. And when x equals 3, y equals, is this x plus 4? Yeah, 3 plus 4, 7. So we get 3, 7. And we're done there. Maths 2024, paper 2, last minute, question 4. Solve for 0 less than x is less than 2 pi, so in radians, watch out for that. 5 cos 2x plus pi over 4 equals 3, so it's a trig equation. So I need to rearrange it to make cos the subject. So I take cos 2x plus pi over 4 equals 3/5. And once you make cos the subject, you can do the inverse cos in your calculator. So if I do the inverse cos, I'll get 2x plus pi over 4 equals something. So I'm doing the inverse cos of 3/5. So shoving my calculator into radians, making sure it is, shift cos 3/5 is 0.927. So I'll just write 0.927. Try not to round too much at this stage. So that's 0.927. I need two answers. You always need two answers. So using a cast diagram, cos is positive. So that is not 360 anymore, it's 2 pi. So I'll do 2 pi minus 0.927. And that's just using a calculator again. 5.356. 5.356. Okay, so we've got two answers. So that means that 2x plus pi over 4 equals 0.927. And 2x plus pi over 4 also equals 5.356. So at this stage, I usually make 2x for subject. So 2x equals and 2x equals, taking away pi over 4 from each of them. So 0.927 minus bracket pi over 4 is 0.141, 142 even, and 5.356 minus pi over 4 is 4.571. And if that was just x, we'd be done, but it's actually 2x, and we'll have to do it all the way up to 2 pi. So if I divide these by 2 now, I'll get two answers, but there'll be more answers. Now, you've got two options at this stage. If you're divided by 2, you would realise that then it repeats itself every 180. If you don't like that, what I normally do is at this stage, add the 360 degrees and then divide afterwards. So that's what I'm going to do. So I'm just going to add 2 pi each of these to get more answers in a minute. So I will get that and that. 0.142 plus 2 pi is 6.425. And 4.571 plus 2 pi is 10.854. So dividing all of them by 2, 0.142 divided by 2 is 0.071. 6.425 divided by 2 is 3.213. 4.571 divided by 2 is 2.286. And finally, 10.854 divided by 2 is 5.427. You could write more. I think that'll be fine, and we're done there. Question 5. Question 5. Find the range of values of p such that x squared plus p plus 1x plus 9 equals 0 has real roots. So real roots means b squared minus 4ac is greater than or equal to 0, because 0 you've got real roots as well. So a equals 1, b is the number in front of x, which is p plus 1, and my c is equal to 9. So that gives me p plus 1 all squared minus 4 times 1 times 9 is greater than or equal to 0. Span the bracket, p squared plus 2p plus 1, take your time on that, minus 36 is greater than or equal to 0. And then we can make that a quadratic, p squared plus 2p, 1 minus 36 is minus 35 is greater than or equal to 0. So then examining the roots of that, we can factorise that. And we've got p and p. 7 5s is 35. So plus 7 minus 5. So we've got roots, not solutions to this, just roots at p equal to 5 and p equal to minus 7. So what we always do at this stage with a quadratic inequality is we draw a quick sketch and we put our roots on, just 5 minus 7 y and x, and it is u-shaped because it's a positive p squared. So I just draw pretty rubbish drawing, but you get the idea. That turning point would probably not be there. May well be, but it doesn't really matter. What matters is it's greater than or equal to 0, so it's above the x-axis. So the bits that are above the x-axis are this side and that side. If I was below the x-axis, I'd be in between. So now I can immediately just say that p is less than or equal to minus 7 and p is greater than or equal to 5, and we're done there. The number of tigers worldwide is modelled by the equation t, small t, subscript t equals 4,000 minus e to the kt, where t is the number of tigers, t years after the year 2000. Fantastic. How many tigers were there in the year 2000 is part A. So in the year 2000, there's no years after. So the answer for part A is, without any real work, it's a number in front, which is 4,000, but let's show why. So tt equals 4,000 e to the minus k times 0. So that's 4,000 times e to the 0. But e to the 0 is 1, so that's just 4,000. And if you ever get asked initially of what happened at the start, it's always a number in front of you. So there you are. Part B. By 2010, there were 3,200 tigers worldwide. How many will we expect in 2030? Okay, so we know initially there is 4,000. So we can model this equation by saying that in 2010, 3,200 tt equaled 4,000 e to the minus kt. And we can then work out our k, and then we can sub in the time for 2030, which will be 30 years. So that gives us 3,200 over 4,000 equals e to the minus k, and the t is 10 years, so times 10. So 3,200 over 4,000, you could simplify that if you want. That's a 0.8 equals e to the minus 10k, and then take the log of both sides. Log 0.8 equals log e to the minus 10k. Taking the minus 10k in front then, log 0.8 equals minus 10k log e. Now log e is 1, it's base e. So that means that k equals log 0.8 divided by minus 10, and that's a calculator job. So ln 0.8 divided by minus 10 is 0.0223. There's my k. And now I have to work out how many there are in 2030. So in 2030, t equals 30. So our equation, remember, was tt equals a 4,000 e to the minus kt. So we've got tt equals, that will be probably 4,000 e to the minus, well, minus 0.0223 t. So that's 4,000 e to the minus 0.0223 times 30. Calculate a job for that. 4,000 times e to the power of minus 0.0223 times 30 is 2048.882. You can't have 0.882 over tiger though, so let's just say 2049. Question 7. F of x equals 3x squared plus 6x plus 2. Show that f of x plus 1 equals that, 3x squared plus 12x plus 11. Then find an expression for f of x minus 1. And finally, simplify f of x plus 1 minus f of x minus 1 over 6. So we just sub in f of x plus 1. So we've got 3x squared, so that's 3x plus 1 squared instead, plus 6x plus 1, and that is plus 2. Expanding our brackets, we've got 3 times x squared plus 2x plus 1 plus 6x plus 6 plus 2. That gives me 3x squared plus 6x plus 3 plus 6x plus 6 plus 2. That's 3x squared, collecting the terms, 12x, and 3 and 6 is 9, 9, 10, 11. Is that as required? Yeah, as required. Let's do the same for f of x minus 1 then. So that's just going to be 3x minus 1 squared plus 6x minus 1 plus 2. So that was going to give me 3x squared minus 2x plus 1 for the first expansion, 6x minus 1 plus 2, 3x squared minus 6x plus 3 plus 6x minus 6 plus 2. That gives me 3x squares minus 6x plus 6x is no x at all. Then you've got 3 minus 6 is minus 3 plus 2 is minus 1. And we're done there. Part C. Simplify f of x plus 1 minus f of x minus 1 over 6. So we've got f of x plus 1 minus f of x minus 1 over 6. So f of x plus 1 is 3x squared plus 12x plus 11. And we're taking away this one, so minus 3x squared. That a minus minus is a plus 1 over 6. So watch out for that. Collecting terms on the top, 3x squared minus 3x squared is no x squareds. We've got 12x, and then you've got 11 plus 1 is 12 as well, all over 6. Well, they can be both divided by 6. 12 divided by 6 is 2x. 12 divided by 6 is 2. 2x plus 2 would be fine, or you could even do 2 bracket x plus 1 if you want to take a common factor, but you probably don't need to. That's 2024 last minute paper 2, question 8. Show that sine 2a over tan a is 2 cos squared a. Usually I stick to the left hand side and try and turn it into the right, so that's what I'm going to do. So let's start off with sine 2a over tan a. Well, sine 2a, start of the exam paper is 2 sine a cos a. And tan a, well, I need to get rid of that tan because there's no tan on the right hand side. Well, tan is sine over cos from National 5. So divided by sine a over cos a. Now, dividing by a fraction is the same as timesing by its reciprocal. What do I mean by that? I mean, you can just flip it. 2 sine a cos a times cos a over sine a. So now, you can see that and that cancel. So you just write cancel. So that equals 2 cos a times cos a is cos squared a. And we're done there. In the coordinates of the stationary points of y equals x to the 4 minus 8x squared plus 3, determine their nature. So stationary points means derivative equals 0. So we write that stationary points occur when dy by dx equals 0. So dy by dx, take the power down to the front, 4x, take away 1 for the power, minus 2 8s or 16, take 1 away for the power, and 3 disappears, and we're going to say that equals 0. So, common factor, that's 4 and x, giving me x squared minus 4 equals 0. Factorise further, well that's double brackets, because it's the difference of two squares, x minus 2 and x plus 2. So our stationary points are 4x equals 0, so x equals 0, x minus 2 is 0, so x equals 2, and x plus 2, so we'll go x equals minus 2. So that's the x coordinates of our stationary points, and we'll do for nature. Do we need the y as well? The coordinates, yeah. We'll go back and get the y in a minute. So for nature, usually do a nature table. So we've got x and then dy by dx. And I'm going in the vicinity of minus 2. And I usually do them as separate ones, in the vicinity of 0, even if I use the same number, and in the vicinity of 2. So we've got that kind of look. Let me just make that a dotted line because it's the same as the other one. You might just go along minus 2, along 0, along 2, along, and most of the time you'd be fine with that. It's just sometimes when there is a point where it doesn't work, you're going to get in trouble. So then we just try some numbers. Now you can do these just in your calculator. So before minus 2, let's just try minus 3. We've got 4 times minus 3. And then that's times by, well, minus 3 minus 2 is minus 5. And that's times by minus 3 plus 2, which is minus 1, which is minus 60. So I'm going to write negative. At this one, it's 0. In between minus 2 and 0, I'll just try minus 1. So 4 times minus 1 is minus 4. Minus 1 minus 2 is minus 3. minus 1 plus 2 is 1. That's positive. So we get positive here, so that means that one's positive. That's 0. Between 0 and 2 is 1. So we've got 4 ones is 4. That's positive. 1 minus 2 is minus 1. That's negative. And then 1 plus 2 is 3. That's positive. A positive times a positive is a positive times a negative is a negative. So you're going to get negative here, and then 0. And then after 2, let's check 3. 4 3s is 12. That's positive. 3 minus 2 is 1. That's positive. 3 plus 2 is 5. That's positive. Positive times positive is positive is positive. So our shape is down, along, and up. Up, along, and down. Down, along, and up. So that is a min. That's a max. And that's a min. And we need our coordinates. So remember, y was equal to x4 minus 8x squared plus 3. So when x equals minus 2, y equals, being careful, minus 2 to the power of 4 minus 8 times minus 2 squared plus 3. That's plus 3. That's minus 13. So minus 2 minus 13 is a minimum turning point. Equals 0, y equals 3. So 0, 3 is a maximum turning point. And when x equals 2, y equals 2 to the 4 minus 8 times 2 squared plus 3. Just to show you, 2 2s are 4 times 2 is 8 times 2 is 16. 2 2s are 4, 4 8s is 32 plus 3. 16 minus 32 is minus 16. Minus 16 plus 3 is minus 13. So 2 minus 13 is a minimum turning point. And we're done there. SBA Higher Maths 2024 Paper 2 Question 10 last minute. So a school splits its whole into 3 sections. We've got senior students only, any students, junior students, and it can be modelled by these equations. So we've got minus 6x squared minus 24x plus 72 here, and then we've got minus 6x squared plus 6x plus 72 here. And we have to find the area of the 3 sections. So there's lots of ways to do this, but basically you've got one section here, another section here, and then you've got this kind of middle bit. So if I want the area of this section, I'm going to have to do this area minus just this little bit. And then if I want the area of this section, I'm going to have to do between these two numbers. And if I want this one, I'm going to have to do the area of this section, then minus this little bit, because you've got that section there. So we're just going to do it like that. So let's start off with first section then, area from minus 6 to 2. Well, just this area here, from here to here. So from minus 6 to 2, that is minus 6x squared minus 24x plus 72 dx. So we need to integrate. So add 1 to the power, that's x cubed, divided by the new power. 6 divided by 3 is 2, so minus 2x cubed. Add 1 to the power, that's x squared. 24 divided by 2 is 12, so minus 12x squared plus 72x. And that's between minus 6 and 2. So we need to sub everything in. Did you know? I just double checking. So I've got sub it in, minus 2 times 2 cubed, minus 12 times 2 squared, plus 72 times 2, and then you need to take away, and we've got minus 2 times minus 6 cubed, minus 12 times minus 6 squared, 72 times minus 6. And then let's work all that out in a calculator. I'll do a little bit without just to get the numbers right, but make sure you use your calculator whenever you need to. 2 cubed is 8 times 2 is 16, so I've got minus 16. 2 2s is 4, 4 times 12 is 48, so I've got minus 48. And 72 times 2 is 144, so I've got 144 here. Again, use a calculator anytime you want, don't be smart like me. Take away. 6 cubed. 6 cubed is 216, times 2 is 432, minus times a minus times a minus times a minus a plus, so it's 432 there. 6 squared is 36 times 12 is minus 432, and then 72 times 6, I'm pretty sure is 432 as well, but let's just check. Yes, it is. So another minus 432 here. So now just putting all these numbers in my calculator, I've got minus 16 minus 48 plus 144 is 80. Take away should be obvious. 432 minus 432 is nothing. Minus 432 is minus 432. So I've got a double minus. Minus 432 plus 80 is 512. If you're not sure of that, just use your calculator. So there we go. We've got 512 for our first area, and we've got 2 or 3 more to do. So now we've already got this bit. So we then want to take away this bit in the middle for when we do this. I also want to know this bit. So it's integral between 0 and 2 of the same thing again. Integral between 0 and 2. Minus 6x squared minus 24x plus 72 dx. So x cubed, 6 divided by 3 is 2, so minus 2x cubed minus 12x squared plus 72x between 0 and 2. So when we sub that in, we get 2 to the power of 3 is 8 minus 16. 2 2s are 4 times 4 times 12 is minus 48. And 72 times 2 is 144. And then that's going to be taken away 0 because we sub in 0 to all that. So minus 16 minus 48 plus 144 is 80. So we get 80 is our other integral. So keeping track of the bits that I've done so far, the first one I've done was this whole integral here, all the way over there. I'm going to call that A for the whole thing. And then I did a B one, which was just from here to here. So that was like my B bit there. And now what I'm going to do is another whole integral. This whole bit here will be C. And then I'm going to do this D bit, which is between here and here. So I'm going to use this new equation, minus 6x squared plus 6x plus 72. So my next integral is the integral between, I've got minus 3 and 4 of 6x squared minus 6x squared plus 6x plus 72. So minus 6x squared becomes minus 2x cubed. 6x is x squared and 3, and then 72x. And then we want to sub in minus 3 and 4. So again, you sub in 4, and you take away the subbing of minus 3. Do all that without me spending ages on the video doing it, you get an answer of 343. And then our last integral is going to be between, for this D part here, minus 3 and 0. So for this D part, between minus 3 and 0, so the same one, minus 6x squared minus 24x plus 72. And that gives us minus 2x cubed plus 3x squared plus 72x between 0 and minus 3 and 0. So when you sub in 0, you get 0 minus, well, let me do this one. So minus 3 cubed, 3 3s are 9 times 3 is 27 times 2 is 54. 3 3s are 9 times 3 is 27. And 72 times 3 is 216. And that's going to be a minus. So that gives us 54 plus 27 minus 216 is 135. And it's minus minus, so that's positive 135. So there we are there. We've got 135 on this side and 80 on that side that we've worked out. And then we've got 512 and 343. So we know that this is 512 and this is 343, but we want to know how big this bit is in here. So I need to take the whole of it minus these two numbers. So 512 minus 135 minus 80 is 297. So this one's 297. And the other side, I need to do 343 minus these two numbers. 297 to start with. 343 minus 135 minus 80 is 128. So we get 128 on this side. And that is our 4 bits. We need the total area of this bit, of course, because the question asked it. So 135 plus 80 is 215. So that bit here is 215. So there's our 3 areas, units squared, and units squared. And we're done there. It's been quite a maths today. We've went through the whole of SQA Higher Maths 2024 last minute paper 2. Hopefully you found that useful. If you did, give it a like and a thumbs up. Take care, stay safe, and goodbye.